Hey, what's up, Math 8? This is Mr. Bainey, and we're going to look at Lesson 5.3, Linear Relationships and Bivariate Data. Our essential question is, how can you contrast linear and nonlinear sets of bivariate data? We're also going to take a look at writing some more equations, something that we've been practicing for a while now. In the last two lessons, we've looked at tables and graphs and descriptions and written equations from those things. We've already, in previous modules, learned how to graph and learn how to find slope and learn how to find y-intercept. So we're kind of pulling all of that together. Okay, so let's take a look at the first your turn on the next page. And we have these your turns. Find the equation of each linear relationship. So if you recall, we need to write this in the form of y equals mx plus b. And we have to find the slope and the y-intercept so we can kind of plug in those numbers and then write our equation. So from a graph, remember that we're going to find 2 points. They give us a ton of points here, but we only need 2. So let's just choose, I don't know, this point that I have in red and then this other point here. And I want to find the rise and the run. So this one's going to be a little tricky only because our scale, you have to pay attention to our scale on the left side. This looks like it goes by 20s. So 20, 40, 60, 80, 100. So it looks like it goes up 2 boxes, which means it goes up 40. So the rise is, it went up 40. And then the run, it went over on the bottom here, looks like it goes by 5. So 5, 10, 15, 20, and so on. So it goes from, it goes over 2 boxes, which means our run is 10. So that means that 40 over 10, our slope, they don't give us enough space to put all of this here. So 40 divided by 10 is 4. And then our y-intercept is, let's put this in a different color. It's this point at the beginning of the line. So remember, it's where the line crosses the y-axis. And so our y-intercept is 20. So when I write my equation, I got y equals mx plus b, or y equals 4x plus 20. And that is it. From a table, it is a little bit different. We've done this before already. So if you can go ahead and pause it and give this one a try. And remember that you're going to find slope, and then you need to find y-intercept. Finding y-intercept is the one that's more tricky. So use the y equals mx plus b. See what you can do with it. Okay, go ahead and pause it. The solution is going to come up here in a few seconds. First thing I did was find the slope. And I looked at just the first 2 points. You could certainly look at these other ones, but not necessarily, especially if we already know this is linear, so it's going to be the same rate of change throughout, constant rate of change. So I went from 480 to 3,600 for my y, so I subtracted on the top of my slope 3,600 minus 480, and then on the bottom 15 minus 2. I have to subtract my x's. So when I subtract those, I get this fraction, 3,120 over 13. I use my trusty calculator, I divide those, and I get 240 as my slope. So once I know what my slope is, I'm going to pick a point. And so I choose the first point. It's the smallest numbers. So from that, the first thing you see here in pink, y equals mx plus b, I change y to 480 because that's what the y is for my point. M, I changed to 240, that's my slope. X, I changed to 2 because that's my x from the point, and then plus b. So I'm trying to figure out what b is here. I multiply 240 times 2 to get 480, and then I figure out I got 480 on both sides, so those go away. Then I have b equals 0. So I don't have a y-intercept, or I mean my y-intercept is 0, and that means that this is a proportional relationship. So I could write it as y equals 240x plus 0, or if you look at this in the back of the book, it's just going to have y equals 240x. What we'll also be able to do once we have an equation is we'll able to get some more points or some more what they'll call in this lesson are they'll call them predictions. So I'm going to do another example, one of the your turns, next page. And at the bottom of page 143, let's see how it works for predictions. This is going to be part of your homework. So Paulina's income from a job that pays her a fixed amount per hour is shown in the graph. We're going to use the graph to find the predicted value. So I could either do this from an equation or from the graph. Either way is going to be fine. And number 6 says income earned for working 2 hours. So 2 hours, the hours is on the bottom on the x-axis down here. So I'm going to look for 2, and 2 is right here. And I want to go directly up to the line, whatever that is, and I get this point right here. So that is, looks like $30 for our income. And number 7 is where it gets a little bit trickier. So if we want to find the predicted value, for that, we would have to go to 3.25 as close to it as possible. So I'm going to mark it on the graph. Let's choose a different color. Mark it on the graph as close as possible. And if I go directly up, I get this point right here. So that looks like it's about $50. Okay, but I want to show you a way to do it without trying to estimate it. What we could do is write the equation of the line. So I'm going to do it off to the side. And if I want to try to find the slope and the y-intercept, so the y equals mx plus b, I know that my y-intercept is 0 because I see it starting at the origin. And then if I do my slope, my rise over run, I'm going to go way up here and do my rise from the second to last point to the last point. So my rise goes from 60 up to, looks like 90, so that's up 30. That's my rise. And my run, it looks like it goes over 2 boxes to the right, so that's a 2. Okay. And remember, this only goes by 1s on the bottom. This goes by 10s. Okay, so if I take 30 divided by 2, I do get 15. So I get y equals 15x, since that 0 doesn't really do anything. And if I want to know the income earned for working 3.25 hours, I just do y equals 15 times the number of hours, 3.25, okay? Because x is the hours. So I'm going to use my calculator and do 15 times 3.25, and I get $48.75. So that's the exact amount for number 7. $50 is sort of our estimated value. So it truly is using the graph to find the predicted value. That's what, if you go back up to the directions, use the graph. So we just won't get an accurate reading because it's hard to know exactly what the value is. Okay, and then number 8 says the total income earned for working for 5 8-hour days, all at the standard rate. So 5 8-hour days. So 8 hours, we got to know how much that is. So for 8 hours, there's a different color here. 8 hours is way over here, like way off to the side, right? So it's going to be up here somewhere. What I could do is I could use my equation again and figure out for 8 hours how much that is. So I could do, all right, so I'm giving you some options here. I could do, whoops, I could do y equals 15 times 8. By the way, that 15 means $15 per hour, or $15 for every single hour. It goes up 15 bucks. So 15 times 8 looks like it'll give me $120. And we're going to work 5 of those days, or Pauline is going to work 5 of those days. And so 5 times 120 is going to give us our answer. Okay, and that looks like 600. Okay, so here is another way you can think about it. Go back up to the graph. From my last point, I could go up 30 again and over 2, and that will bring me to that point that I want for 8 hours. And so this is from $90, right? Sorry, it's hard for you to see. That's $90. So if I go up 30, that's 120 bucks. And over 2 would be for 8 hours. So 8 hours would be $120. So you could still use the graph. You're going to go off the graph a little bit, which is fine. You just have to be aware of how to read it above the graph. And then you multiply that by 5 and you still get the same answer. On this next page, I'm not going to actually do this explore activity. I just want to point out a couple things because this isn't new. We've actually looked at this before, um, but for the past 3 modules, we have been looking at relationships between 2 things, between X and Y. We've been looking at proportional relationships, non-proportional relationships, whether they're linear or non-linear, all those things. So you have been quizzed, you have been tested on these things. It just gives you a more formal definition here. A bivariate data is what we've been working with. It's just anything that's made up of 2 variables, x and a y, so that we can graph it. And then if it's linear, we know the rate of change is always the same, it's constant. If it's not constant, it's a non-linear relationship. So if you'd like to go through that, go through this explore activity, you may. I can look over it if you like, but I'm not going to do that here. Okay, and that's going to be it for this lesson. Thank you so much for watching. Hope it was helpful. Good luck on the homework and have a great day.